Okay, guys, today I'm going to be reviewing Module 6. This is the chapter we did in fourth grade for division, and this is as far as we'll go for division in fourth grade. The first thing we did is we took a word problem that was a division problem, and we had counters. We had little circles. This division problem was 42 divided by 3. So we made groups of 3 with our counters. We took all of the counters and made groups of 3. And after we were done, we could count how many groups we had. And we ended up with 14 groups. So 42 divided by 3 equals 14. Okay. We really understood that. We know that we can take things and put them in equal groups and count how many groups there are. And that gives us the answer to the division problem. The next day, we introduced having division problems with remainders. This was a problem about Elise having 35 pencils, and she wants to make 8 party bags. And she's going to put the same amount of pencils in each party bag. So we learned to do this using an array. A says draw an array to represent 35 divided by 8, 35 pencils divided into 8 party bags. Now, we learned as third graders that arrays are equal rows. So we knew we needed to have 8 rows, 1, 2, 3, 4, 5, 6, 7, 8. And then we distributed those 35 pencils, or circles in this case, evenly into those 8 rows. But when we got done, we realized there were 3 that were not going to make even rows. So those 3 were going to be left over. Each bag is going to have 4 pencils in it. Each one of these 8 bags is going to have 4 pencils in it. And then we're going to have 3 pencils left over. So down on D, the whole number quotient is 8. The whole number quotient is 4, and the remainder is 3. So the answer to the division problem is 4 remainder 3. Okay. Kids understood that really well as well. The next day, we started talking about ways to interpret the remainder. Here I have 4 different word problems that are essentially using the same division problem. The division problem, we figured that out on the board with circles. 10 divided by 3, we realized we were going to have 3 with 1 left over. 10 divided by 3 is 3 remainder 1. That was a really simple problem for us to figure out. But then, what if we put that division problem in a story problem, a word problem? And we have to think about the way that remainder affects the answer. For instance, number 1, 10 soccer players are going to a game. 3 players can fit in a car, so how many cars do they need? Well, there's no such thing as 3 remainder 1 cars. So a lot of students said, well, we take 3 cars, Miss Johnson. We just leave off the remainder 1. I said, well, but that means 1 kid doesn't get to go. There are 10 soccer players. If you only take 3 cars, only 9 kids can go. How many cars do we need to take? So they realized quickly that we need to, add 1 to the whole number quotient. We're going to need to take 4 cars, even though one of those cars is only going to have 3 kids in it. The next scenario, 3 friends share 10 cookies. Now, cookies, if you've got a leftover cookie, those 3 friends can take that cookie and cut it into thirds. So really, each friend can have 3 and 1/3 cookies. The third scenario, mom's making treat bags. She puts 3 toys in each bag. How many treat bags can she make with 10 toys? Well, we know 10 divided by 3 is 3 remainder 1, but you can't make 3 remainder 1 treat bags. You can make 3 treat bags and have 1 leftover toy. And then finally, this question, if you pay attention to it, let me move my picture. It's specifically asking how many are left over. How many are left over? If it's asking how many are left over, we're just going to write the remainder on there. Okay, let me move my picture back down and then go to the next slide. The next day, we started using this grid paper and thinking about area models. We know about area already. Like if we know the inside of a square or rectangle, we can tell you what the length and the width is. So here we have the division problem, 63 divided by 3. So on grid paper, the first thing we do is we did a line on the side going 3 down. We're going to make 3 rows. Okay, so then what we did, and I don't have the tools to do that on my computer, with our pencil, we went and made 63 dots. We counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and we kept going all the way to 61. We counted all 63 dots. And then once we had those dots, we knew we had 3 rows, and we had to count how many was in each row. And we could actually complete our rectangle to make an area model. So this is a total of 63 little squares. 3 rows of 21 make 63 little squares. So we figured out that 63 divided into 3 rows is 21. And then we took that a little farther. We don't want to count every single one of those squares. There's got to be an easier way. There's got to be an easier way without having to count all of those little squares in the grid. So for this problem, it's 92 divided by 4. And I'm thinking about multiples of 4 in my head. And I'm thinking about things that are easy to get to multiply by 4 in my head. And I know that 4 times 20 is 80. Okay, so if I break this long rectangle into 2 pieces, this piece can be 80, and then I'll figure out how much is left after 92 there. So this piece is 80. That means 80 divided by 4, and that's 20, because 4 rows of 20 is going to make 80. Well, then I can do 92 minus 80. I'm going to have 12 left. That means this box right here has to have 12, because 80 plus 12 is 92. So if this box has 12, and you kind of can see that one's not too hard to count. 12 divided by 4 is 3. There's 3 columns right there. So 4 rows of 3 is 12. So now I've got the whole 92 in there, but I broke it in 2 pieces. Those 2 pieces are called partial quotients, because a quotient is the answer to division problem. These are 2 parts. So partial quotients, 20 and 3 are partial quotients. So I can add 20 plus 3 together and get 92 divided by 4 equals 23. The next day, let me move my picture. The next day we introduced distributive property. That's kind of what we were doing already. Distributive property is when you break apart your dividend into smaller pieces that are easier to divide by. I have this area model rectangle over here. It doesn't have a grid. We're not always going to have grid paper, and we really don't want to count all those squares anyway. So we could just draw a simple rectangle and fill it in and say what it's going to be. So in this problem, it's 217 divided by 7. So we have to break up 217 into 2 parts that both numbers are easy to divide by 7. Now, for us grown-ups, that comes fairly easy. I can break 217 into 210 and 7, 210 plus 7. But I really had to underline the first 2 digits of this number and have kids look at a list of multiples of 7 and realize, hey, 21 is a multiple of 7. And I know how to do 21 divided by 7, so I'm going to know how to do 210 divided by 7. That took some thought on their part to be able to figure out how to break that apart. So next, we took those 2 parts, that 217 that we broke into 2 parts, and we put both of those parts in our area model down at the bottom. And then we figured out what 217 divided by 3 was, and 210 divided by 7 and 7 divided by 7 were. I'm going to put those over here. 217 divided by 7 is the same thing as 210 plus 7 divided by 7. And we broke that into 2 smaller division problems. 210 divided by 7, that's going to be this box. And 7 divided by 7, that's going to be this box. Okay. Well, 210 divided by 7 is 30, so we put 30 here. 7 divided by 7 is 1, so we put 1 here. And then we just add those 2 partial quotients together to get our answer is 31. I showed students they could do it just with the numbers, or they could do it with this rectangular area model. it doesn't matter which way they do it. They do need to know how to do both ways on the test. The next day, we started repeated subtraction. Okay, they learned in third grade when you were first learning how to multiply, you learned that multiplication is the same thing as repeated addition. Like 3 times 5 is 5 plus 5 plus 5. So multiplication is repeated addition. That means the inverse of that, division, has to be repeated subtraction. So if we want to do 36 divided by 5, if we just keep subtracting 5 over and over again, we should be able to get the answer. It says use repeated subtraction to divide. Start with the dividend. The dividend is 36. Subtract the divisor as many times as you can. The divisor is 5. We're going to subtract 5 over and over and over again. Okay. And then we're going to count the number of times we subtract. I put that in. They did the subtraction for us in this problem, but we subtracted 5 7 times. Okay? We subtracted 5 7 times, but we still had 1 left over. That's going to be the remainder. Okay? So the answer to 36 divided by 5 is going to be 7 remainder 1 because we took 7 5s away with 1 left over. But when you answer this word problem, you have to pay attention. It's asking how many swimmers are on a team. You can't have 7 remainder 1 swimmers. There must just be 7 swimmers. From here, we jumped to a higher level and we started thinking about ways to relate the area model that we've been doing with the repeated subtraction that we've been doing. We've got this problem. Hank loads 848 snack packs onto 4 airplanes. So how much is on each plane? Well, here's our area model. We broke 848 into 800 plus 40 plus 8. And we know 800 divided by 4 is 200. And then 40 divided by 4 is 10. 8 divided by 4 is 2. We add these 3 partial quotients, 200 plus 10 plus 2 is 212. So there's 212 snack packs on each plane. Now we're adding on to that. What if we, instead of doing an area model, we take what we know about repeated subtraction? Now, this is a very large number. I do not want to subtract minus 4, minus 4, minus 4, minus 4, minus 4, minus 4 over and over again until I get rid of 848. So we started thinking about groups of 4. I'm going to take a large chunk of 4s all at once. A lot of times I'll ask my kids, can we take 100 groups of 4 all at once? 100 groups of 4 is 400. What about 200? Can we take 200 groups of 4 all at once? And that's what they did in this one. They took 200 groups of 4 all at one time. 200 groups of 4 is 800. So they took, instead of saying minus 4 200 times, we're going to go ahead and take 800 away. And we're writing over here on the side, that's 200 groups of 4 that I took away. 848 minus 800 is 48. And then I need to think about how many groups of 4 I could take away. Well, if I can't do 100, my next real easy multiple of 4 would be 10. So I'm going to take 10 groups of 4 away. 4 times 10 is 40. So we can take 10 groups of 4 away. 48 minus 40 is 8. Ooh, and then 4 times 2 is 8. So I can take 2 groups of 4 away. And then finally I get 0. Now, to get my answer, I need to go back to what I recorded on the side. I took 200 groups of 4 away. I took 10 groups of 4 away, and I took 2 groups of 4 away. 200 plus 10 plus 12 is 212. There's the answer. This method is the method that your students are going to be using the most often. And this is as close as they will come this year to the standard algorithm or the shortcut method that we learned when we were students. They won't learn the final long division until 5th grade. And they won't be expected to master long division until 6th grade. 5th grade, they'll practice it. 6th grade, they'll master it. Okay. So here's another one. I'm going to do another one like this one on the side. We call this the partial product method using repeated subtraction. Okay. So, sorry, I didn't mean partial product on the last side. I meant partial quotient. We're dividing. The partial quotient method using repeated subtraction. So this one was 862 divided by 7. First thing I ask every single time, can we take 100 groups of 7 away? 100 groups of 7 is 700. We subtract 862 minus 700, we get 162. And then I start thinking about multiples of 7. I even might look at just the first 2 digits and tell my kids, hey, 16 is pretty close to 14. I know 7 times 2 is 14, so couldn't we do 7 times 20? And they go, yeah, we can take away 20 groups of 7, Miss Johnson. So 20 groups of 7 is 140. We subtracted, we got 22. And then we look at our list of multiples of 7. 22 is really close to 21, which is 7 times 3. Subtract and get 1. Once again, we added all these partial quotients. 100 plus 20 plus 3 equals 123, but we can't forget we had 1 left over. So the answer is 123 to remainder 1. Let me show you another problem like this. I just did 2 problems. Let me move my picture again. Okay. I did 511 divided by 8 2 different ways because, as I tell the kids, there are so many different ways to do this. As long as you're taking out groups of 8, eventually you will get to, we have only 7 left. So on this one might be a kid who's using a strategy. They start with, can we take 100 groups of 8 away? That's 800. No, that's too much. So let's cut 100 in half. Can we take 50 groups of 8 away? Yeah, 50 times 8 is 400. And we get 111 left. And then we can take out 10 groups of 8. 111 minus 80 is 31. And then we're thinking about our multiples of 8. 24 is the closest thing to 31 without going over. So 8 times 3 is 24. Subtract, we have 7 left over. Add these 3 partial quotients, 50 plus 10 plus 3, and get 63, remainder 7. Now, a different student might think about this a different way. A different student might think about just these first 2 digits of this 511, and they see 51. And they think, okay, what multiple of 8 is closest to 51? Well, 6 times 8 is 48. So I can do 60 times 8 and put 480 here. And I'm going to subtract 480 all at once. 511 minus 480 is 31. Now we get the same thing here. And we know that we can subtract 24 because that's 3 groups of 8. So here I took away 60 groups of 8 and 3 groups of 8 to get 63, remainder 7. Even though we did it 2 different ways, we still end up with the same answer. So this is the final method your students have learned. But they're responsible for all those models, the area models, being able to do it with the counters, being able to do that repeated subtraction. And then next year, they'll learn long division. Okay. I hope this helped. I'm going to stop my video. If you need to pause or rewind and watch again, hopefully you understand your 4th graders' understanding of division.